theorems called the factor theorem and the polynomials. Just focus. Okay. I'm not going to derive the theorems. I'm just going to maybe mention a little bit about why the theorems work and then give a couple examples how you would use them when factoring a four-term polynomial. So the factor theorem first says that if you got p of x, your polynomial, and if you evaluate the polynomial at b and it gives you a 0, and that means that x minus b is a factor of p of x. And that's really nice because that means all you got to do is find a value b, plug it in p of x, and if you get a 0, you got a factor. Problem is that, well, I guess b could be any number, right? Well, not really. And I'll show you why you won't be guessing in the dark. The key number that helps you not guess in the dark is this number right here, the minus 12. So imagine what a factored form of a polynomial looks like. At least a polynomial with a lead coefficient of 1. When it's factored, it's going to look like this, right? And when you multiply these binomials out, you're going to get an x third to the third term, an x squared term, an x term, and then you're going to have a constant here, right? Well, where does that constant come from? It's going to be the product of a, b, and c. Well, that must mean that a, b, and c are factors of this constant. In other words, back to our polynomial here, a, b, and c are going to be factors of 12. Okay, so now you know that this number that you're looking for to plug into p of x to get a 0 can't be something like 5, because 5 is not a factor of 12. Okay, so that cuts down on your choices. So our choices are cut down to all the factors of 12, positive and negative. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. Still kind of a long list, so not that great, but it's still a lot better than picking from all the integers in the world. Alright, and I recommend that you start with the lower numbers, just because they're easier to work with. So again, the factor theorem tells us if you put b into p of x and you get a 0, then you found a factor. So all I'm going to do is start with the lower numbers and put them into the function and see if I get a 0. Let's start with 1. So p of 1 will give me 1 plus 1 minus 8 minus 12. Okay, I can already see that that's not going to be 0. So now I'll go to p of negative 1. And that gives me negative 1 plus 1. Got to be careful with the negatives here. Plus 8 minus 12. That's also not going to be 0. Now move on to 2. 8 plus 4 minus 16 minus 12. Possibly. Let's see. 12. No. This is 12 minus 16, negative 4 minus... Okay, that's not going to be 0. So right now I'm starting to dislike this polynomial. This looks good. That's going to be negative 4 plus 16 minus 12. Okay, that's 12 minus 12. That is 0. Okay, so I have one factor already. X plus 2 is a factor. Now I don't need to use the same process, this plugging and chugging process, to find the other factors, because now I can use long division, divide by x plus 2, and I know I'll get a quadratic, and the quadratic I can factor by other means. But since we've done long division in other videos before, I'm going to do this using synthetic division. So I put the coefficients here. I put the negative 2 here. Notice I put the negative 2 the actual root, not the plus 2 from the factor. I bring the 1 down. Negative 2 times 1 gives me negative 2. Then I add here, negative 1. Multiply negative 2 times negative 1, give me 2. Add. And then negative 2 times negative 12. Negative 2 times negative 6 is 12. That gives me 0. And then these are going to be the coefficients of my quotient, my quadratic, x squared minus x minus 6. And that I know is x minus 3, x plus 2. Okay, so all three factors of my polynomial are, I'll write it like this, x cubed plus x squared minus 8x minus 12 is x plus 2 times x minus 3 times x plus 2. So I got two identical factors there, but that's okay. Alright, so we used the factor theorem there to help us get the first factor. Then we just use division. You can use long division or synthetic division to find the breakdown for the last two factors. Now I'm going to do another one using rational root theorem to help us out. Okay, so this polynomial's lead coefficient is not 1, it's a 2. And I purposely chose that because rational root theorem tells us something about polynomials where the lead coefficient is not 1. So since the lead coefficient is not 1, that means at least one factor in the factorization is going to be of this form, ax minus b. And the other factors may have that form as well, or they may not. They might just have a lead coefficient of 1 for the x. So that gives us an added aspect to look at when we want to plug in p of b to get 0. So the rational root theorem says that p of b over a, if that is 0, then ax minus b is a factor. Okay, so what are b and a? B represents all the factors of that number right there, the constant 2. A represents all the factors of the lead coefficient, that 2. So this is what I mean. The factors of this 2 are 2 and 1, positive and negative, and the factors here are also 2 and 1. So then all the possible b over a's that I can make are plus or minus 2, plus or minus 1, plus or minus 1/2. Okay, so let me explain where those came from. So the plus or minus 2 would be the 2 that is a factor here over the 1 that is a factor of this. 1 would be 1, which is a factor of this, over 1, which is a factor of this. 1/2 came from 1, which is a factor of this, over 2, which is a factor of this. So these are all the possible roots. And now I can choose the one I want to start with to plug in to see if I get a 0. 1/2 is a little more work to deal with because I'm cubing and squaring. So I'm going to start with the 1s. So p of 1 gives me 2 plus 5 plus 1 minus 2. Okay, that's not going to be 0. P of negative 1, negative 2 plus 5. This feels better. Minus 1 minus 2. That is a 0. Okay, so I know that one of my factors is x plus 1. And just like in the other example, that's enough to get me started. So I'll do synthetic division again. 2, 5, 1, negative 2, negative 1. Bring down the 2, multiply, add, multiply, add, multiply. Got a 0. Okay, so that means x squared plus 3x minus 2 is my leftover trinomial. And that is, oh sorry, 2x squared plus 3x minus 2. And that should be factorable. Yeah. There we go. So my final factorization of 2x cubed plus 5x squared plus x minus 2 is x plus 1, 2x minus 1, and times x plus 2. Okay? So that's for theorem and rational root theorem, helping you to factor longer polynomials. Thanks for watching K109 Math, and we'll see you later.